what are the apparatus we need. So we need what are the apparatus. So first you see the diagram. You already know this diagram, isn't it? You already studied in characteristics of motor, and you studied about the types of motor. So you know, you all are familiar with this circuit diagram. So these are the circuit diagram of shunt motor. So see, what is this? So you know that shunt means armature and field winding should be connected armature, and for series connection, armature and this field winding should be connected in series. So this is the, you know, this type in theory. Okay, so you can see the circuit diagram. Dimensions 3-point starter. So this is LFA. Already you studied starters also. Okay. Now we can. What is this? So from this circuit diagram, you take those components. Okay. So here, what are the apparatus we require? So we need ammeter. Okay. So ammeter is 0 to 20 amps. We are taking the range 0 to 20 amps. Why? The specification limit is up to 20 amps. Okay, so you're taking the apparatus requirement also. The range is 0 to 20 amps. Now, whether my voice is audible to you?
Ma'am, break ma'am, Papa.
Okay, now can you hear me? Okay, come to our experiment. So what are the, then you need voltage, isn't it? So voltmeter. So voltmeter, we can here the range is 0 to 300 volt. Okay, so 0 to 300. Here also we know that the specification of our rated voltage is 220 volt. So we are taking 0 to 300 volt as our range. Okay, similarly, here we are choosing rheostat. We need rheostat for varying this field. Okay, varying this current in the field. So here the resistance is rheostat is 370 ohm. So already we know that comparing to armature resistance, our field resistance should be higher, isn't it? So here see, the rheostat here is we are choosing 370 ohm. Okay, and the current range is 2 amps. So then you need tachometer. So what is a tachometer? Why we are using tachometer? Tachometer is used to measure the speed. Okay, so speed of the motor can be recorded through this tachometer, that is digital type. So here our speed will be measured in digital form. Okay, so these are the apparatus we need for shunt motor. So what is this here? See, this is a brake drum. Okay, here the motor will be coupled to this brake drum. Okay, so this is brake drum. So that's why we are calling here this as brake test. Okay, we are calling this as brake test of shunt motor or brake test of series motor. So why we are calling this brake test? So this motor will be connected to this brake drum. Okay, so this is brake drum, and here the value is S1, S2. I will tell about this in later in detail. Okay. Okay, initially we are providing here DC supply. Okay, we are providing the, because this is a DC machine. Okay, so we are providing the DC supply, and switches are, while the experiment is conducted, we are closing this DPSTS switch. Okay, so one another main thing is you have to calculate the fuse. Okay, so how will you calculate this fuse? This fuse will be calculated by using the formula 120% of rated speed. So rated current. Okay, so 120%. 120% means what? for calculating the fuse rating, the formula is 120 or 125 percentage. Okay, so 120 or 125 percentage of the rated current. So how will you take this? Here the rated current is 20 amps. So you have to calculate the formula 120 by 100 or 125 by 100 into the current. Okay, so what will be the value? So you have to find value and calculate it. Okay, now, okay, to that rotor. Okay, here the rated current value is 20. Okay, so you have to substitute 120 by 100 into 20. Okay, you have to say the value. What is the value? Ma, whether audible? You can interact with me. Amo sir.
ஹலோ ஹலோ மேம் சொல்லுங்க. ஹலோ ஜெனிதா மேம். மேம்
Sir,
இடையில
கேக்குதா?
அப்பப்ப பிரேக் ஆகுது மேம். அதான்
sir,
இடையில
நான்
பிரேக்
பேசுறது
ஆகுது.
கேக்குதா? சார் ரொம்ப
ரொம்ப
பிரேக்
பிரேக்
ஆகுது bro.
ஆகுதுங்களோ அப்பப்ப இடையில பிரேக் ஆகுது, காரணம் இல்ல.
அப்படியா? ஓ சரி சார், ஓகே சார்.
மேம் கண்டினியூ பண்ணுங்க மேம்.
We know the theory part, isn't it? Okay, sir. So we know already. We know you have studied theory part. All those three classes also you studied in theory, isn't it? So now you can directly go to our experiment. Okay. So see the tabular column. So this theory is nothing but you studied already the types of series, these types of motor, isn't it? So same thing here. So just we can go the tabulation and procedure. So this is a tabulation. See here, what are the things you have to calculate? So actually, what is the thing our main aim is to find those things, isn't it? Those you have to calculate, you have to plot the graph, plot the characteristics, isn't it? So for the characteristics, what are the requirements we need? So we need you have to find the efficiency. First, for finding the efficiency, what is the thing? You have to find the output by input. So our efficiency formula is output by input into 100. Okay, then you have to we have to find the output power also. Output power and input power, you have to find it. Okay, so how will you find it? So output, see here, you come from backward. Okay, so efficiency, you have to find it. Efficiency is equal to output by input into 100. Then output is equal to, what is the output formula? So already we have see this in characteristics, isn't it? So output is equal to 2 pi nt by 60 watts. Okay, so these are the things you have to perform the calculations. Okay, so you have this part fully you have to find it when you have to calculate it. Okay, so first we can see this, what are the requirements you have to need for this calculation. Okay, so what are things you have to find the speed also. So you have to find the speed. Okay, so there will be one speed tabulation. Then we have to find the torque, isn't it? So see the formula. The formula is nt. So you have to find the speed on tabulations, and you have to find the torque also. You have to need the tabulations. Okay, so see here, initially the tabulations consist of voltage, current. Okay, then input power. So input power, you have to find the output power and input power also. Okay, so for that we have to, main thing you have to find is voltage. Okay, voltage, current. Then by using this current and voltage, you can find the input power, isn't it? So next we have to find the S1, S2. Already we know that, I already show you that S1, S2, isn't it? So what is it? So we are going to apply this for our load test. We will be applying, each time we will be applying the load to this motor. We will be applying load. Okay, so that time we will be calculating the S1 and S2 of this value. Okay, Okay, now we can go to the run the experiment. So initially we have to see the precautions. Okay, so while connecting, first procedure you have to do the connection diagram as such. Okay, how will you do this connection diagram? Connection, any idea how to connect? That will be show you later. Is okay, that video will be show you later. Okay, so you have to connect this as such. The circuit diagram, you have to connect the circuits. Okay, so see here, so this is a DC supply. Okay, you are taking a DC supply, so you have to check the polarity. Okay, so minus to plus polarity, you should be careful to mark it. And here also see MC. Why you are pointing this as MC? MC, if in AC supply you will be will be marking as MI. You'll be using moving coil. So that is represented as MC. For AC supply, AC instrument, we'll be using moving ion. So that will be represented as MI. Okay, see here, these are the representation. So ammeter, we have to point this. If ammeter means, you have to circle, you have to mention this in this symbolic representation, and you have to mention the polarity. For DC supply, you should denote this polarity also. Okay, minus positive, that polarity also you should be. Okay, so first initially precaution, there are two precautions. So what are the precautions? So first you have to give the connections. You have to ensure that the connections are given properly. Okay, so that is the first step. Then here there is a rheostat, isn't it? This rheostat, here the resistance should be in minimum conditions. Okay, so initially for motor, this resistance should be in minimum. Resistance means nothing but this rheostat. Okay, this rheostat, it should be in minimum condition. Okay, you have to, what is minimum? Okay, that will be shown in connection. Okay, that connection diagram will be shown to you later, or I will share you YouTube. Okay, in YouTube I will show the connection, how to give the connection, like that I will show you later. Okay. Okay, so first step, you have to give the connection. Next, you have to ensure that this is a shunt motor. So it should start with no load. Initially, you have to ensure that the motor is the belt. This is a belt, isn't it? So here you have to check it whether this is whether any load is initially applied, or whether this. How will you check? You can just check this breakdown. Okay, that belt to this conveyor, it should be. You have to check. Okay, இப்போ என்னன்னா நமக்கு அந்த லோட் கனெக்ஷன் பண்ணீங்க அப்படின்னா இது நீ வேரி பண்ற மாதிரி இருக்கும். ஸோ வேரி பண்ணும்போது இதில் அப்ளை பண்ணும்போது அந்த பெல்ட் வந்து உனக்கு வந்து டைட்டா இருக்கும். ஸோ யூ ஹேவ் டு செக் தட் இனிஷியலா லோடு வந்து அப்ளை ஆயிருக்கா இல்லாட்டி அப்ளை ஆகலைங்கிறத நீங்க வந்து இனிஷியலா செக் பண்ணணும். ஓகேவா? ஓகே, ஸோ ஃபர்ஸ்ட் பார்த்தீங்கன்னா இனிஷியலா நோ லோட்ல தான் நம்ம வந்து ஸ்டார்ட் பண்ண போறோம். ஸோ நோ லோட்ல ஸ்டார்ட் பண்ணி ஃபர்ஸ்ட் யூ ஹேவ் டு டேக் த ரீடிங். ஹவ் வில் யூ டேக்? ஃபர்ஸ்ட் யூ ஹேவ் டு ஸ்டார்ட் த மோட்டார். ஹவ் வில் யூ ஸ்டார்ட்? இப்போ நீ வந்து என்ன பண்ணணும் அப்படின்னா, அந்த இனிஷியலா நம்ம ஸ்டார்ட் பண்ண பிறகு அந்த சுவிட்சஸை க்ளோஸ் பண்ணிடணும். ஓகே, இது சுவிட்சஸ் க்ளோஸ் ஆன பிறகு நம்ம என்ன பண்ணணும், அந்த ஸ்டார்டரை வந்து ஸ்லோலி ஹவ் டு வேரி. ஓகே, யூ ஹவ் டு வேரி த ஸ்டார்டர். Okay, it will be just like knob. Okay, you have to vary the. Already நம்ம starter பார்த்திருக்கோம் இல்லையா? For why you are using starters? Can anyone say the answer? E&I department, mechanical, triple E. 3 classes are here. So anyone can answer this? Okay, you have to note it. This is a Viva question for you. Okay, so you have to submit me. Mechanical student, you have to submit it me. Okay, you have to start this with no load. These are the Viva questions here. You have to answer it. Okay, so initially now you have to set what is it, the condition. First you have to start the motor with rated voltage. Okay, so first step settings you have to carry out with initial rated voltage and rated speed. What is the rated speed? 1500, isn't it? So 1500 RPM is our rated speed. Okay, so first we have to start it with no load. So initially I will run the motor by wearing the starter. Okay, so now I am starting with the help of starter. Now the motor, now you vary the rheostat. Okay, now you have to vary the rheostat. What is the rheostat? Here we connected to the field winding, isn't it? So you have to gradually vary the knob of the rheostat. So finally, 1500 or 5. How will you check the speed? The speed will be checked through tachometer. Okay, tachometer it is used for measuring the speed. Okay, so just you have to hold the tachometer in this brake drum here, the motor position, and you will be viewing the speed. The speed will be 1500. Okay, so you have to set the speed as 1500. So until okay, now you take the tabulation reading. So what is the tabulation reading now? Okay, see the tabulation. So first reading is initially what is the voltage? Voltage will be 220 volt because we are initially we are giving the supply 220 volt. Okay, so initially we are giving the voltage 220 volt. So the voltage will be 220. So similarly, what is the current? Okay, you have to measure the current. Okay, so what will be the current? Next, this S1, S2. Okay, so you the S1, S2. Initially, there will be 0 because for no load test, the value will be 0. Bigger only. Okay, in S1, S2 reading will be 0 because we have does not applied any load. Next, these are things are okay. So first you can write this voltage. We know this. Okay, this voltage we can measure by the voltmeter. The current also we can measure it through ammeter, and the S1, S2 reading will be shown in this meter S1, S2. Okay. Then speed. Already you know that now the speed will be 1500 because you are setting the speed to 1500. So the speed will be 1500. This is your first reading. Okay. Other things you have to calculate it. Okay. Other things you have to find it through the formula. Okay. Next, what is the procedure? First, we made it with no load. Next thing, you have to apply load. Okay. Initially, you are making some next measurements, next readings you have to take with load. Different types of load. You are see what is the thing? You have to adjust the load. So that will be shown in video. Okay, that video I will be showing that. So here you will be varying the, you are applying some load. Okay, so if you apply the load, what will be the thing? The S1, S2 I'm reading. The ammeter also will show some reading. So what is the value of ammeter now? Interactive section. Okay, for lab section you should interact with me. Any doubt also you can ask me. நம்ம லோட் கொடுக்க current வந்து என்னவா இருக்கும்னு சொன்னேன். Current also will get increasing, isn't it? So now the current will get increased. Okay, so that reading also will be noted. Okay, so what will be the voltage? So now second reading, see, so you will be taking for with load. Okay, so from second reading you will be taking with load. So when we apply the load, so you have to see the voltage. What is the value of voltage? Okay. Next, what is the current value? So current will be getting increased because as the load is applied, the current also will get increased. Okay. So similarly, S1, S2. So S1, S2 also there will be showing some reading. So you have to note down this value. Now you have to see the speed. What will be the speed? How will be, anyone can tell me? Speed will be increased or decreased? Now open your mouth. Answer me. Speed will be decreased or increased? While we are giving our load, the speed will be decreasing. Okay. So similarly, current will be increasing. Okay. This is the nature. This is the important thing you have to note down here. Okay. Then similarly, you take the 5 set of readings. Okay. One reading you take with no load reading. Another 5 readings you will be taking. Okay. For load, you are taking adjusting the load and you will be applying the load and we will be finding voltage, current, and S1, S2 value and speed. These are the things we will be note down. Okay. We will be taking readings from the experiment. Other things you will be calculating. See this efficiency, output power, torque, and net force. That is S1 minus S2. This one, input power. This all the thing we have to find it by doing calculations. Okay. Okay, another main thing is you shouldn't, this current value shouldn't exceed the rated value. Okay, here the rated value is 20 amps, isn't it? For our DC motor, the given nameplate details is below 20, sorry, 20 amps is the rated current, isn't it? So the current shouldn't exceed the 20 amps. Okay, so you have to ensure that this is very important. Our machines for machines lab, you have to take safety procedures. That is very, very important. Okay, we'll be taking the reading, and finally, what is the thing we have to calculate? See here, this is a model graph. We will be finding what are the things, finding the efficiency. See our experiment. Okay, output power, input power, output power, efficiency, torque. These are the things we have to find it. Okay, so how will you do calculations? See what are the formula I will show you. See here, this is the formula. Okay, what are the things? See the output power of the motor. So what is the formula? Formula is S1 minus S2 into RE. What is the RE? RE means radius. Okay, radius, what radius of brake drum. Okay, I already show you the brake drum. You have to find the radius of the brake drum into 9.81. Okay, so this is the formula. Okay, into that speed in radian per second. Okay, so here these are the formula. Okay, so that is 2 pi nt by 100. Okay, you can take it as like this. So next, input power is V into IL. Okay, so you know that voltage, we already find voltage, current. Next, see this efficiency. See here, the formula here is tabulation. Here also there is a formula. So you can take this formula here. So before finding the efficiency, you have to find the torque and output power, input power. Okay, then only you can find the efficiency. So here there is a formula. So that only we are here finding S1 minus S2. So what is S1 minus S2? See here, S1 minus S2 means these two values difference. S1, S2 difference only the net force. S1 difference S2. Okay, so you have to subtract these two values and you have to do the calculation and put it here. Input voltage means you have to multiple this voltage and current. Okay, so that is power. Power formula is voltage into current. So you have to multiple this voltage and this current. You have to multiple it and you have to write it here. Next, torque. See here, this is a torque formula. So torque formula is F into, what is this F? F means the S1 into S1 minus S2 into radius into 9.81. So in this torque you have to write here. So how will you calculate radius? How will you calculate radius? Radius of the brake drum formula is, you have to first find the circumference of the drum. Okay, what is the circumference formula? Already you know that circumference is 2 pi r, isn't it? From this 2 pi r, you have to okay. I'll be telling you for your formula. The circumference formula is 2 pi r. Okay, that is your circumference. So what is the thing? You have to measure it with the tap. See, this is the brake drum, isn't it? Okay. So this is your brake drum. Okay, this is your brake drum. Here you have to measure with the wire. You have to measure this radius. Measure this with a centimeter. So you'll be getting some around 65 or 60 something. Okay, you'll be getting the centimeter. That is equal to 2 pi r. Okay, you listen. You have to measure this radius. You have to measure the brake drum. You have to measure this brake drum. You take some wire and you measure it. It will be around 65. So 2 pi r equal to 65 means that you have to find the radius. So radius, how will you find r 65 divided by 2 pi? You will be find some value in centimeter. You can convert it to meter. Okay, so that is your radius. Okay, for all the experiments you will be calculating the, for series compound also you'll be finding the radius. Okay, the radius will be same. So you have to, okay, this is the torque. So what is it? This F is equal to S1 minus S2 into that radius into 9.81. That value will be torque value. Okay, you have to calculate and you have to find this here. Next, output power. So output power formula is 2 pi nt by 60. Okay, so you replace here. What is the formula? 2 pi nt by 60. For each load, okay, for each load will be speed will be varying, isn't it? So every time, so 2 pi t by 60. So that will be the output power. Okay, so all the thing you have output power also you calculated, input power also calculated. Now you can find the efficiency. So efficiency is equal to output by input into 100. Okay, that is this output power divided by input power. That will be the efficiency. So now all the things you have calculated here in the tabular column. Now you can just draw the graph. Already we know the graph, isn't it? Already we have studied the characteristics of DC motor in theory part. So already we know the nature of the curve. See this is the, here I have, see in y-axis, we have commonly take speed and current, the torque, efficiency, all the things we have taken in the same axis. So in the same graph, we are receiving this, all this graph, okay. So you are taking x-axis, you are taking output power. Okay, how will you plot? You have to take x-axis. In x-axis, you have to take the output power. So in y-axis, you have to take the efficiency, torque, speed. All the things we'll be taking in y-axis. See this, already we know. This is the, we know the speed torque characteristics, isn't it? Other one important thing. Speed motor is always called as constant speed. Okay, it is called as constant speed motor. Okay. Why we'll be telling this shunt motor is a constant speed motor? Because here that flex will be almost in constant. Okay, so here the speed will be nearly constant. Okay, see that if we do it experimentally, we will be receiving the RPM is 1500. So you'll be 1460, 80, that range only. That nearly the graph will look like a constant, nearly constant. Okay, So this already we studied this in theory part also, isn't it? Okay, so these are the, see, this is the speed curve. So the speed and the power. Here we are receiving this curve. And similarly, torque will be looking like linear characteristics. This is a torque. So you'll be receiving, while after the plotting this from the tabulation, you will be receiving this nature graph. Okay, so efficiency will be like this. Okay, so this graph will be plotting depending upon our reading. This will be plotted based on our tabulation. Okay, once you find the calculation of the tabulation, you will be plotting. So the plotting results will look like this. Okay. Okay, here are some Viva questions also. So note down it and you have to submit it. Okay, all those Viva questions. So all of you note down this question. This question you have to take it as homework. Okay, see Viva questions. There are 3 questions. So all you have to note it down now. Okay. So this is our shunt motor. Okay, finally we are calculating the efficiency also. Similarly, based upon the shunt motor only, it depends upon series motor, compound motor, all like that same thing. Calculations, graph, all the one similarly like this. Okay, but what is the condition? In series motor, we should start with initial load. Okay, I already informed you why the series motor should start with load. Anyone can answer now? Now you have to answer. Anyone can answer? Already I asked you in theory part also. I answered you. Tell me. Amo sir. Hello? Ma, whether it is audible to you?
Yes, ma'am.
Kekida, Amo sir. Okay, ma, DC shunt motor, anyone having doubt with this? You can ask now. You can ask your question. Now our shunt motor is completed. You can ask. Amo sir.
சொல்லுங்க மேம், கேக்குது.
கேக்குதா சார்? கொஞ்சம் ஒரு 5 நிமிஷம் கண்டினியூ பண்ணுங்க சார், நான் இப்போ வரேன்.
அப்படிங்களா?
இப்போ ஒரு நிமிஷம் 5 நிமிஷம் நீங்க கண்டினியூ பண்ணுங்க, நான் வந்துடுறேன்.
என்ன பண்ணணுமா
சார்? ஷண்ட் மோட்டார்ல யாராவது டவுட் கேட்காங்களான்னு பாருங்க.
ஓகே,
அப்படின்னா சீரிஸ் மோட்டார் கண்டினியூ பண்ணிட்டுங்க, நான் வந்துடுறேன்.
இல்லை நீங்கள் 5 மினிட்ஸ் நான் வாங்க, அப்படியே வெயிட் பண்ணுறேன், ஒன்றும் பிரச்சனை இல்லை.
அப்படியா? ஓகே சார். ஸ்டூடெண்ட்ஸ் ஏதாவது டவுட் இருந்ததுன்னா கேளுங்க. இந்த வைவா கொஸ்டின்ஸ் இருக்கு இல்லையா, இந்த வைவா கொஸ்டின்ஸ் இப்போ நோட் பண்ணுங்க எல்லாரும். ஓகே, வைவா கொஸ்டின்ஸ் உங்களுக்கு ஹோம்வொர்க். நீங்க வந்து அனலைஸ் பண்ணி என்ன ரீசன்ங்கிறத நீங்க வந்து கம்ப்ளீட் பண்ணணும் ஒவ்வொரு எக்ஸ்பெரிமெண்ட்லயும். ஓகேவா? ஹலோ, ஆடிபிளா
மேம்
இருக்கா?
கண்டினியூ பண்ணுங்க மேம்.
ஓகே சார்,
கண்டினியூ
கண்டினியூ
பண்ணுங்க.
பண்றேன். ஓகே மா, ஷண்ட் மோட்டார்ல ஏதாவது டவுட் இருக்கா? Anyone having doubt in shunt motor? Okay, then can we go for next one? Next is series motor. Okay. Okay, see here. Similarly, you are going to, what is the aim of our test? We have to find the load test and we have to plot our performance characteristics, isn't it? So what are the characteristics we are finding? We'll be plotting the curve for efficiency. Okay, so you're finding the efficiency and torque value will be finding, and we are finding the relation between speed and the output power, and finally torque speed. Okay, so these are the characteristics we are performing, isn't it? So same thing here also, in series motor also we'll be performing those tests. Okay, so similarly the apparatus range, all the ones similar like shunt motor. Okay, so see here one major difference. So this is our circuit diagram. Already we know the circuit for our series motor, isn't it? So what is the difference here? See here, the field is connected in series with the armature terminals. Okay, so in series motor the field will be getting connected in series with the armature of the motor. Okay, in shunt motor this field will be connected parallel to it. Okay, you have to note down this. This winding should be connected in parallel, means that is shunt motor. Okay, so see here, already we know that here we are using 2-point starter, isn't it? Already we in starters we studied 3.4 point 2-point starters. So series motor is a 2-point starter. Okay, so here main thing is, while starting the DC series motor, the main precaution is you should start this motor with load. Okay, what is the reason why our series motor should start with load? Can anyone say this? Can anyone say this? Answer me, whether right or wrong. Okay, so what is the relation between speed and the, what is the relations between speed and the flux? We already know that n speed will be directly proportional to voltage and flux will be inversely proportional. We already know this, isn't it? So in this case, if flux get decreased, what will be the result? So if flux is decreased, what will be the result? The result is speed will be high, isn't it? So at the start, while it is starting with no load condition, will be that flux will be very low, isn't it? That current will be very low. So when the flux is low, what will be happen? The motor will run at a dangerous speed, isn't it? So because n will be inversely proportional to flux, so this case the speed, it will run at a dangerous zone. Okay, that motor will run at a dangerous zone. So for that purpose only, the DC series motor should run with the load. Okay, so already sir informed you what are the applications. Sir already informed you, isn't it? So where are the applications we will be using this DC series motor? Anything? Crane, train. So these are the applications will be operating their motor with load, isn't it? So the DC series motor, where are the applications we'll be using? We'll be using in train, cranes, like that. We are operating here the motor with load. Okay, so these are the general. Now we can go for experiment. We saw the nameplate details. So in circuit diagram, you have to display this nameplate details also, and you have to find the fuse rating. Already I saw you how you have to find the ratings, isn't it? How will you find? 120 by 100, 125% of rated current up, then 125 by 100 into the rated current. That is your fuse rating. Okay, you have to find it. So for all experiment, main thing you have to do is you have to find the fuse rating and you have to write the nameplate details. For all the machines, nameplate details is very essential. Okay, so that we have to precautions. You have to very precautions whether the machine is operated within the safe limit, that is within our rated voltage or rated current or rated RPM. Okay, so this is the precautions. What is the precautions here? So you have to DC series motor should be started and stopped with some load. Main thing, okay. Motor should be started with and stopped also with some load. Okay. Similarly, while giving the supply is disconnected, then in shunt motor you have to bring back the position to no load. Okay, so we can't able to just off the machine like that. Okay, in shunt motor, normally how you started the machine, same procedure only. You have to go back with no load and then you have to disconnect it from supply. Okay, this is main thing. According to machines, you have to follow all those precautions very much. Okay. Okay, first we can go directly to the tabulation because this one similar to other test only. See here, what are the things? Already this tableau column, you are familiar with shunt motor. What is the thing? Voltage, you're finding the current, and S1, this one spring balance, spring reading balance S1, S2. This all the thing in the tabulation is similar to the shunt motor. Okay. So how will you find? So okay, now you can start our experiment. How will you run our experiment? Initially, you have to check whether the connections are given properly. Okay, so the circuit diagram you have to. I will show you the connection. How will you give the connection like that? I will video. I will give you later. I will share you through YouTube. Okay. So first you have to give the connections according to our diagram. You know the diagram, circuit diagram, isn't it? So you have to give the connections first and you have to check whether the all initial adjustments, that is rheostat, is whether rheostat is so first you connect this diagram. First, you have to apply some load and you check whether the brake drum is tightening. Okay, so that means there will be belt here connected, so you can check through this. Okay, so the belt the brake drum should be connected, that belt will be tightened. Okay, so then there will be some load applied. Okay, so now you can start the procedure. So now you switch on the supply. Okay, so in switch on the supply, then what will think you have to so now initially you will be setting to the rated speed, isn't it? So you'll be finding 1500 RPM. So next you have to in tabulation you find when you take the reading, you'll be displaying some volt. Okay, that rated voltage you know that 220 volt. Okay, so 220 volt and corresponding current you will be measuring, and here S1 S2 here the S1 S2 will be showing some reading. Okay, but because initially we are running the motor with some load. Okay, so here there will be some S1 S2 value, so you'll be the S1 S2 difference will be, you have to calculate and place it in this table. Then you have to find the speed. Similarly, you will be finding for different readings. For different readings, you will be taking the we are varying the load each time, and while varying, you will be voltage, current, speed are noted respectively. Okay, then you will be similarly will be finding for five set of readings. You take it with load adjustments. You adjust the load and you find the different set of readings for 5 readings. You find it and then you calculate similar to shunt. Already I explained you that. So speed, you can calculate the torque, you can calculate the input power, you can calculate the output power, and you can calculate the efficiency. These calculations are similar to shunt motor that I explained you earlier. Okay. Now see here, Okay, already I show you how to calculate the radius of brake drum, isn't it? So here there is formula is here. See here the circumference is equal to 2 pi r. Okay, so circumference, that is, then for calculating the radius, what is the formula? Radius is equal to circumference by 2 pi. That means the circumference, how will you find? You have to find the overall circular or that brake drum circumference, you have to find it. So that value will be 65 or 60 something. Okay, so that value by 2 pi, that is your answer. Okay, that will be, you can convert it to meter. That will be the radius of the drum. So this is a diagram. See here. So this will be same thing. We will be see here, output power will be in x-axis, and although speed, torque, efficiency will be in y-axis. You just take the reading and plot it as a curve. Okay, so that you will be finding this similar graph. You will be getting the result. Okay, so these are things similar to our shunt. The only case is, what is that? You have to start, the C value should be within the rated value. Okay, so what is the rated condition? 20 amps. 20 amps is your rated value. So always you should be aware of that. Okay, always you should be aware whether the current is within the limit, within the safe limit. So you have to be careful. So you can take the reading within rated values. Okay, above the rated values you can't be take. Okay, you shouldn't. You should be take very precautious. Okay. So this is a series motor. So similarly, we'll be finding the compound motor. Okay, series motor, shunt series. Whether you have doubt, you can ask me now. Okay, see here. Now we can see the cumulative and differential. Here you know that DC compound motor will be operated with differential and cumulative. There will be two connections, two types, isn't it? So already we saw in theory also. So it will be this also similar to our shunt motor. Shunt series shunt motor, it will be similar to shunt motor. See here, these are the nameplate details. Already we know that for any machines there will be rated specifications. Okay, so here there is a voltage rating, current rating, and speed, field current. Okay, all those ratings are rated specifications are given here. So always you should be careful with this. So whether your machine is operated within this safe zone. Okay. So here there is a formula for fuse rating. So here there is a formula. You can take it for 3 motors also. 125% of rated current. So here 125 into this 12. This 12 is here, the rated current is 12 amps. So 12 by 100, that is your fuse amps. Okay, that is fuse 15 amps. This is your fuse rating. So the types of motor. For all experiment, you will be finding the fuse rating. The apparatus is nothing but it depends upon the circuit. So what are the circuit? What are the components we are using? We just display it in apparatus. Okay, and the range also. So range for the so one main thing. See here, always our ammeter field. Okay, that field current should the ratings will be 0 to 2. Okay, always there will be range is between 0 to 2 amps. Okay, there will be less amount of current flow in the field. Okay, so that we need 0 to 2 amps is enough for that. Okay, so we are preferring 0 to 2 amps. In load side, we'll be connecting 0 to 20 amps because we know that up to rated values 20 like that. Okay, so we are need this 0 to 20 range. This one for load side. Okay, this one for field side. Okay, armature side and field side. Ammeter. Okay. So we already know voltmeter, why we are taking 300 volt, because here this is a rated voltage is 220. Okay, so we are taking the range of 0 to 300. So already other things we discussed in shunt motor. Okay, so you can directly go to the experiment. See, this is our circuit diagram. Here there is some diagram based on our panel. Okay, they will be showing the panel display here. This like this only will be the motor also will be looking like that only. Okay. So already you know that this is field winding. This is a motor. So this is our positive minus our supply. Okay. So here we can view our voltage, ammeter, field ammeter. Okay, then ammeter here RPM, speed will be displaying here. This is our panel display. Like this, the board will be looking like that. Okay, so all the things will be interior connections. Okay. Okay, see this diagram. What is the change in this diagram? So in compound motor, you know that compound motor, it is a combination of series and shunt, isn't it? So there will be two windings. See here one field winding and here one winding. Okay, there will be consist of two winding, one series winding and one shunt winding. So that two winding combination is called as compound motor. Now here the circuit looks like, see here, you have to draw it carefully. I will share you this diagram later, okay? Because here you have to, here directly they are taking from MCB board and they are showing the diagram also here. So that's why it looked like different. Here you can see that here two-phase supply is given, and again taking the, but we are taking our supply DC supply only. See here we are taking only DC supply. Okay, so that's enough for you. I will share you this diagram later. Okay. So other things, see here, you can see from this. So you are taking the DC supply only. From among this supply, you are carrying out the DC supply only. You are taking the DC supply and we are taking this to the field and you are taking to this armature. Okay. So here see, this there is a field winding here and there is a armature winding here. Okay. You are taking this and this both combination only, it is shunt compound motor. The procedures are same as shunt motor only. Okay. So here also, what are the thing? How will you take this reading? How will you run the motor? All the thing you have to ensure that the field should be kept minimum. Field resistance should be initially kept minimum. You have to ensure that the connection is given properly or not. Okay, you have to ensure whether the connections are properly made and the field rheostats are kept in minimum position, and you have to, here also will be starting with no load. Okay, so all the thing you have to precautions should be done before doing our experiment. All those precautions should be done carefully. Similar like shunt. Okay, but this is similar like shunt. So see here, all the things similarly, the tablet column also similar to the experiment. Only thing is here, we are doing both type, that we know that differential compound like the two types are there, isn't it? So here we are doing connections for both thing, cumulative compound. Okay, what are remaining things same as shunt motor. Only change here we are taking for two types. Cumulative type means here we are connecting this winding, isn't it? Already what is cumulative, what is differential? What is cumulative, what is differential? So already explained that, isn't it? When the flux aid each other, that will be cumulative type. When the flux will be in opposing type, that will be differential type, isn't it? So here see this. For that we can just perform the winding, this series winding, you can just interchange. Okay, if we interchange, you will be getting differential connection. Okay, so just by interchanging the connection here, that y1 y2 isn't, see the winding y1 y2, just we have to interchange this both terminals, then you can get it for differential connection. Okay, similar other thing, it's same as shunt motor. Okay, see here same tabulation only. So we are finding the voltage, ammeter, and this one speed. This always will be for all experiment will be finding the voltage, current, and speed. Okay, here we'll be finding the field current also. Already we know that the formula is IL is equal to IA plus IB. This all the things we'll be finding with the calculations. Okay, other things same thing. Okay, other things already, if operations are similar to shunt. Okay, so just you can, so this is a tabulation. So we will be finding, only thing is you have to first find the cumulative compound. Next you have to change the connection, and you'll be finding the second set of readings. The connection procedure will be same as shunt motor. Okay, all the things I will share you through video mode. Okay, and now we can just see the theory part. So here are the Viva questions. Okay, so I will share you this manual also. You have to answer those questions also. It will be useful for your objective questions. So here are more than 100 questions are available as Viva question. So from this Viva, you can make use for your exam. Okay, you have to prepare it. Next is speed control. Okay, see here already you both previous thing you saw the load test. Okay, by varying the load you are performing the experiment, but in this speed control you are just varying the voltage. Okay, just you are varying the rheostat and you will be varying the speed only. Okay, you are not adjust, you will won't take care of the load. There just you can controlling. How will you control the speed? Already some anyone answer what are the methods for speed control? Speed control of DC motor, what are the methods are there? Can anyone? May anyone answer you? What are the methods? We already discussed in theory part. Whether right or wrong, just answer. Okay, first we can see the theory. So we can just revise the theory. So what are the controlling methods available? There are field control and armature control. So what are the two types? So here we are going to see armature control, field control. In theory part we already studied about Ward-Leonard control method also. So in our part, we are in the lab experiment, we'll be performing armature and field control method. Okay, so this is very important. In speed control of DC motor, it is very important, and there are more Viva questions related to speed control. Okay, so what is our aim? Speed control of DC motor, what is our aim? So you have to control the speed by using armature control and field control. Field control method otherwise called as flux control method. Okay, field control is otherwise called as flux control method. Then main thing here, there will be speed below the rated speed, above the rated speed. The speed below the rated speed is achieved. Okay. Similarly, by controlling the field, above rated speed will be controlled. Okay, these are the things we are going to perform here. So for this experiment, you will be see virtual class also. That virtual lab also, it is available in this experiment is available in virtual lab also. So you can do this experiment. So now we can see the theory part. So just you can see the circuit diagram. So apparatus is nothing but what are the components we need for our circuit. We just placed it in apparatus. Okay, these are same thing as previous case. Because we are seeing all shunt only, all shunt type motor only now we are discussing. Just now can see the controlling speed. How can we control our speed? Okay, first we can see the armature control method. So what is, first you see theory part, then we can go to the experiment. So what is armature control? And for this control, speed control, we have to know the speed relation. Okay, so what is the speed relation? Can anyone tell? Speed relation. For armature, what are the expression will be taking, and for field control, which expression will be taken? Already we know that speed will be directly proportional to voltage. Okay, because what is the speed relation? N is equal to EB by pi. Okay, what is the relation? V is equal to, sorry, N is equal to EB by pi. Okay, so EB, what is the EB? V minus IARA. V minus IARA by pi. Okay, initially we are operating with no load. So that IARA, the terms will be 0, isn't it? Here we are with no load only are operating. So our equation now becomes N is equal to EB by pi. Okay, now so first case, for armature case, we will be taking N is equal to directly proportional to V. EB means what? That is voltage, isn't it? So N will be directly proportional to voltage, and for flux control method, N will be inversely proportional to flux. So these are the things you are going to take it for theory. Okay, based on this theory only, you are going to do the practical. Okay, understand here? N will be directly proportional to V. So what is the thing? By varying the voltage, the speed also get varying, isn't it? If you increase the voltage, the speed also will get increasing. But the increasing case is not possible in armature control. Why? Because initially we will be applying rated voltage. Initially we will be applying rated voltage as 220 volt. We just can't increase the voltage, isn't it? We can decrease the voltage, but we can't increase the voltage beyond the rated level. Okay, so when we decrease the voltage, what will happen? The voltage and speed will be directly proportional. So when we decrease the voltage, the speed will be decreasing. Okay, when we decreasing the voltage, speed will be decreasing. Okay, so this so the armature control method is applicable for the speed lower than the rated speed. Okay, this is the armature control method. Okay, next theory part is field control method. So what is the field control method? So in field control method, the speed will be inversely proportional to flux. So in this case, see here, when the flux is getting decreased, what will be the thing? The speed will be getting increased, isn't it? So when the field across the current is get decreased, what is the thing? Field and the flux are in same proportional, isn't it? The flux will be depend upon the field current, isn't it? So if the field current will get reduced, what will be the thing? If the field current get reduced, what is the thing? The flux also will be getting decreased. So when the flux is decreased, speed will be increasing because that is inversely proportional. So when the flux is decreasing, speed will be increasing. So in the field control method, by controlling the field current, we can, by controlling the field current, sir, கேக்குதா? Hello?
மேம் கேக்குது. வாய்ஸ் ஆடிபிள்.
ஓகே சார், ஓகே. ஓகே சார். கட் ஆன மாதிரி இருந்துச்சு சார் இடையில.
இல்ல வாய்ஸ் கேக்குது, ஒன்றும் பிரச்சனை இல்லை.
ஓகே. Okay sir, okay. So upon flux, while the flux is decreased, the speed will be increased. So so in field control method, the speed above the rated speed is possible. Okay. So here we are above the rated speed and below the rated speed we are performing in speed control method. In armature control, the speed control below the rated speed we are performing, and in field control we are performing the above rated speed. Okay, so these are the two methods of controlling. Now we can see experimental wise and tableau column. Now we can see the experiment and tableau column. So this is the circuit diagram. So the circuit diagram, it will be similar to our shunt because it is a shunt type, shunt motor, isn't it? So already we learned the shunt diagram. So here see, we are using two rheostat here, okay? Because for one thing for controlling the armature and one thing for controlling the rheostat, controlling the field. So there are two rheostat. So why the one thing for controlling the armature? So we are connecting the one rheostat in series with the armature. Okay, one thing you're connecting to in series and another thing you're connecting in series with field winding. Okay, so this is our circuit diagram. So normal shunt motor, here extra one resistance I am connecting, extra one rheostat I am connecting, because in here we are performing armature and field, both thing we are controlling. So I am taking separate rheostat here. See, the value of the rheostat here is 220 ohm and the value here is 50 ohm. I already told that for armature resistance is always small, less than the field resistance. Okay, so here the resistance is less and the field resistance is higher than the armature resistance. Okay, next thing here we have to main precaution is, see this, the field rheostat is kept minimum position and the armature resistance here it is kept maximum. Okay, see this, the arrow mark is shown that here this arrow mark is given in minimum, connected in minimum condition. Next here, see the in armature control, armature type, armature side resistant, here the resistant rheostat should be connected maximum. Okay, so the arrow mark is denoted in here. Okay, so these are the precaution you have to take before starting the experiment. Okay, first you have to check the connection circuit diagram, and next you have to check the rheostat position, whether it is minimum or maximum. In field the resistance should be minimum, and in armature the resistance should be in maximum. So now you can continue your procedure. So what is the thing? So first we can take the armature voltage control. See here, this is our tabular column. So this is our tabular column. So first you are going to find the armature voltage control. Okay, so what are the things? First you have to keep one armature field current fixed, and you have to vary the voltage and current, find the speed. So what is the thing? I already told you that the relation of the armature thing is the voltage should be proportional to speed. Voltage and speed should be directly proportional. So the voltage, you are taking the relation of voltage and speed. So by varying the armature voltage, what is the speed? Like that you are going to find the tabular column. Okay, so first initially what are the things you have to do? You have to vary the field position. Field you have to vary, and you have to set it with rated speed. Initially what the procedure? You have to vary the rheostat. See the diagram. So you have to vary this rheostat. Okay, you have to vary the rheostat, and you have to set the motor to 1500 rpm. Okay, after, and you have to the voltage also you have to set to rated voltage. Rated voltage, you know, that 220 volt, and the rpm is 1500 rpm. So you have to fix this initial settings, initial ratings. Then you have to start our experiment. Okay, how will you start our experiment? Okay, you keep this field, okay, field rheostat, you keep it as fixed current value. You have to vary the armature current. Okay, the armature voltage, how will you vary the armature voltage? The winding, the slides given here. Okay, the rheostat, by varying the rheostat of the armature side, you'll be getting voltage, it will be decreased, isn't it? While you are changing the rheostat, what will be the thing? The voltage will be getting decreased. So for each value, you take the value, you just vary the rheostat, the 50 ohm 8 amps given, no, that rheostat you vary, and you will be obtaining different voltage. So for each voltage, for each decrease in voltage, corresponding speed in the tachometer is noted. The motor speed is noted. Okay, see here the tabulation. See here, for armature voltage, you can say, take 6 readings you take. For voltage, what is the corresponding speed? Okay, similarly, you vary the armature voltage. How will you vary the armature voltage? Just by varying the rheostat of armature. Just you vary the armature side rheostat, and you vary the voltage. So if you vary the voltage, corresponding speed will be noted in tachometer. Okay. So similarly, the IF2 you can take for another set of reading. Then field current, you now vary the field current to another particular value. Ensure that always our field is only less. Field current will be nearly 0 to 1 or 0 to 2. So you can take the value 0 to 1. Okay, 0 to 1 means you can take as 0.5, 0.6, 0.7, like that you can take it. Okay, so if you keep that value as fixed, you can vary, you can take another set of reading for armature and speed. So finally you'll be getting the curve like this. So this is the speed and corresponding speed and voltage. So here you will be, if you plot the tabulation, you will be getting this curve. Okay, if you plot in the graphical, your graph will be looks like this. Okay, so this is your speed and voltage characteristics, that is your armature voltage control. Now we can see the field control. Okay, so this is a field control tabulation. In field control, you have to fix the voltage, you have to keep the voltage as fixed, and you'll be varying the field current. By varying the field current, what is the thing, speed will be, corresponding speed will be noted. How will you vary the field? Now you just keep fixed, that armature side rheostat is kept fixed, and just vary the field. Okay, field rheostat is here. Okay, that 220 ohm, this rheostat you have to vary. If you vary, you will be getting, the flux will be decreasing, and while decreasing, what is the speed? The speed will be increasing. Okay, for every decrease in the flux, the speed will be increasing. Okay, so if you keep example 0.7, corresponding speed will be noted in motor. So similarly for next reading, you have to vary the rheostat. So what is the thing? Again you will be getting, the field current will be changed, field current will be reduced. So if the field current is reduced, what is the thing? Speed will be getting increased. So whenever the field is decreasing, the armature, the motor will be getting increased. So in the field control method, the speed above the rated speed is achieved here. So see the tabulation. So here you have to make no change in the armature voltage. Voltage you have to keep it as such. You can take it, example, if you take 200 volt, here you can take it as 120 or some 180 volt, like that. Okay, you can take any volt here, but this volt is, I am maintaining the constant, and I am varying the field. So I have to vary the current here. So if I vary the current, example 0.7, 0.6, 0.5, 0.4, 0.3, like that you have to take the reading. Okay, because the range is 0 to 1. You are taking the ammeter 0 to 1 only. So I have to, the values are, because the current flow is very less here. So the value will be 0.8, 0.5, like that range. So whenever the field getting decrease, the speed will be increasing. Here example, the speed will be above rated speed. So 1500, above 1500 will be getting reading. 1600, 1700, like the 2000, like that you will be getting reading here. Similarly for next set of reading, you take it VA2. Again you take the another set of reading as some 180 volt. Now you check it with the speed control. You can take, now similarly you can vary the field and you find the speed control. So now if you tabulate and plot, the graph will be look like this. Now you will be taking current in the x-axis and speed in the y-axis, and your graph will be looking like this. Okay, you have to just plot the curve. Now this is your field control and armature control. So mainly field control method is used for speed above the rated speed. In armature control method, we are performing the speed less than the rated speed. Okay, so these are the way we are controlling the thing. Okay, so here are the Viva questions. So you all make use of this Viva questions for your objective questions. You have to find the answer for this. Okay, this is the homework for you. So any doubt you can ask now. Anybody having doubt? Okay, so next one, Swinburne's test. Okay, so what is Swinburne's test? Swinburne's test is a method we are performing. Here the motor will be, we will be calculating with no load, but we will be performing the machine as a motor and generator. Okay, here we are performing the machine as a motor and as a generator. Okay, this is very, very simple test, but you have more calculation. See, what is the aim of this Swinburne's test? This is also shunt. So we are measuring seeing here is shunt. Okay, all the things we are speed control also we are performing in control also. Same circuit only we are considering for Swinburne's test also. So very easy. See here. So what is the aim? You have to perform the Swinburne's test for DC machine, and we have to calculate the efficiency. We have to find the efficiency for both the motor and generator. So you have to comparison. So what is the efficiency for motor and what is the efficiency for generator? You are going to find here. So this is a nameplate detail. We already know the nameplate detail. This is a shunt motor. You already discussed the nameplate detail, isn't it? So same thing, nameplate detail here we are writing. So apparatus also we know, because already speed control we take this apparatus, same apparatus only for the Swinburne's test also, because we are doing shunt machine. Okay, so taking shunt machine, so same thing on. So this is a circuit diagram. See here, already this circuit diagram is familiar already. Here the main thing, for load test you will be the machine should be connected to brake drum. Okay, you for the Swinburne's test and speed control, this brake drum should not be coupled. Okay, because we are performing the no load, we are not applying any load to the motor. Okay, so the brake drum here, we are not coupling any brake drum to the motor. The main reason is we are performing the Swinburne's test with no load. Similarly, for speed control also we are not applying any load. Okay, only for load test, that series shunt compound, for this type of test alone you are performing the load. So that thing you have to couple the motor to the brake drum. This is very important. Okay, if you draw the load here, this is wrong. Okay, you have to, for the circuit diagram of Siemens, you should be draw like that. Okay, you shouldn't couple it with brake drum, and that means we will applying some load. Okay, so that's why we are using the brake drum coupled for the load test cases. So in these cases we just keep the diagram. So the diagram is same as previous cases. So already we discussed about it. So just we can go the procedure. See, same diagram, same thing. You are giving the connections and you are ensuring the connections are given properly. And every time the same thing, the minimum, the field rheostat should be kept minimum. Okay, that should be ensured for a motor. So for motor, the field should be kept in minimum condition. So see, so directly go to the tabulation. So just you are taking only one set of first procedure is you have to maintain the initial setup is what is the thing, we have to keep all those in our rated value. So just you start the machine and you run the machine by varying the field. You apply the speed to 1500. So you have to set the speed to 1500 rpm. You check whether the motor gains 1500. So until you have to vary the rheostat. So if you vary, the 1500 speed will be provided to the motor. Okay, then you, when the motor, then the similarly the voltage will be what is the rated voltage? Rated voltage is 220 volt, isn't it? So that is your rated voltage for our machine for DC motor. So that will be 220 volt. So the value will be here 220 volt. Then you adjust the field winding. So what if you vary the field rheostat, the speed will be 1500. So just you write the speed as 1500 here. Then you find the current. What is the current flow in the field winding and what is the current flow in the armature winding? Just you take the reading and you note down the reading. That's all. This is the test you are finding, because this is a no load test. Anything, you are not performing any load or no thing. Okay, we are just taking the varying the voltage, or you are varying the field, so that voltage should be in rated voltage and the speed should be 1500. Okay, and the corresponding ammeter reading are noted. The field ammeter and armature ammeters are noted. Okay, so this is the Swinburne's test. So by with this test we are performing calculation for two things, motor and we are running this as generator. Okay, but without loading. Okay, without loading the machine we are performing the motor and generator. The efficiency of the motor and generator also calculated. So here fully formulas we are performing calculations. The here Swinburne's test, the calculations will be more calculations will be there. So here see, for a generator one tablet column will be there, and for motor one tabulation will be there. So this is a motor tabulation. So normally, so all those things are formula I already discussed here. See here, the formulas are given here. You have to make use of thing, and you have to calculate. Okay, so this thing we can perform only when we can find the reading. So I will be giving you readings later. So you have to perform the calculation based on this formula. So all the formulas are given. See here, all those formula. So what are the formulas? So this main thing, input, what is the input, and what is the losses, and all those things you have to calculate. So this thing we can see later, because the calculation you have to by reading I will show you the calculation later. Okay, so you can see this calculation next class. Okay, so if you see this calculation, see, finally efficiency will be calculated. All the things similarly, output also, input power, because efficiency, you know the formula. What is the efficiency? Efficiency is equal to output by input. So that we are finding the output power, input power. So all the things, if you find this, you can find the efficiency also. Okay. So finally, see, this is our model graph for efficiency, and see, this is a motor and this is a generator. So this is a motor efficiency and this is the generator efficiency. This result will be getting based on our tabulation. So the tabulation will be full of calculation. You have to perform the calculation manually. Okay, you just go through the formula and you write down in your note. I will discuss you the thing later. So this is a Simpson's test, and finally you'll be getting the result for efficiency. Efficiency of the motor and generator will be displayed. So here you have to take the precaution. The motor should be without load, no load. Okay, so the machine should be no load, and the field side rheostat should be in minimum position. So all the things you have to take the precautions. So here are the Viva questions. You can make use of it and you can learn this. Okay, now I have completed one cycle. So one cycle we have completed theory part. So next there are some virtual lab also, virtual mode. You can see the experiment through virtual mode. Okay, now I have completed theory part. Okay, so you can see the run through the virtual lab also. Okay, sir, Amos sir, anybody having doubt you can ask. Load test and series, shunt, compound, Simpson's test, speed control. So we have saw those things. We have completed those things. If you have any doubt in this, you can ask me now. Anybody having doubt? Amos sir.
மேம் சொல்லுங்க மேம்.
சார் எதுவும் இன்டரப்ட் ஆகல இல்ல?
ஒன்றும் இஷ்யூ இல்லை மேம்.
ஓகே சார், ரெக்கார்ட் ஆயிட்டு தானே இருக்கு?
ரெக்கார்ட் ஆயிட்டு இருக்கு மேம்.
ஓகே சார். சார் இந்த ரெக்கார்ட் ஆகுறதுலாம் டிரைவ்ல ஃபர்ஸ்ட் வந்தவங்களுக்கு தான் சேவ் ஆகும். யார் இந்த குரூப்ல ஃபர்ஸ்ட் வந்தாங்களோ அவங்களுக்கு சேவ் ஆகும் டிரைவ்ல.
அப்படியா மேம்?
நீங்க ஃபர்ஸ்ட், ஆமா நீங்க ஃபர்ஸ்ட் உள்ள வந்தீங்களா?
நம்ம கச்சடி மெயில் தான் வந்தது. கச்சடி மெயில் தான் வந்தது.
அப்படியா? நீங்க தான் ஃபர்ஸ்ட் ஷேர் பண்ணீங்க அப்படிதானே லிங்க்?
நான் தான் ஃபர்ஸ்ட் லிங்க் ஷேர் பண்ணேன்.
உள்ள லிங்க் ஓபன் பண்ண அப்புறம் நீங்க வந்துட்டீங்கல்ல உள்ள?
வந்துட்டேன் மேடம்.
ஓகே சார், அப்போ டிரைவ்ல சேவ் ஆகும், அதுக்கு தான். ஓகே சார், இப்போ நான் தியரி பார்ட் இந்த இதுக்கு முடிச்சாச்சு.
ஓகே, நான் விர்ச்சுவல் லேப்ல மேம் ஒரு 3 எக்ஸ்பெரிமெண்ட் வருது மேம். நான் 3 நடத்துறேன் நான்.
விர்ச்சுவல் லேப்ல நீங்க இந்த 3 எக்ஸ்பெரிமெண்ட் நடத்திருங்க சார் இப்போ. ஓகே சார், நான் மியூட் பண்ணவா? நீங்க ஸ்டார்ட் பண்றீங்களா?
இப்போ மேம்
இப்போ தான் சார். இப்போ டைம் ஆயிடுச்சா?
மேம் 4:30. நெக்ஸ்ட் வீக் நம்ம இத முடிச்சிரலாம் மேடம்.
ஓகே சார், ஓகே. சோ நெக்ஸ்ட் வீக் அப்போ இதுக்கு விர்ச்சுவல் லேப்லாம் பாத்துறலாம்.
கண்டிப்பா மேம்.
ஓகே சார். சார் அது போக மீதி எங்களுக்கு மெக்கானிக்கல்ல வந்து ஏசி மெஷின்ஸ் வந்திருக்கு. அதுக்கு போக மீதி எல்லாருக்குமே எங்களுக்குலாம் ஏசி மெஷின்ஸ், இண்டக்ஷன் மோட்டார் அந்த மாதிரி வருது. காமனான உள்ளது வந்து இந்த 5 எக்ஸ்பெரிமெண்ட் வந்து எல்லாருக்கும் காமன். இந்த 3 பேருக்கும் இது காமனா இருக்கு. 3 பேருக்கும் கம்ப்ளீட் பண்ணியாச்சு. மேனுவல் இருக்கு சார். இந்த மேனுவல் வேணா அப்லோட் பண்ணிடலாம். ஸோ ஸ்டூடெண்ட்ஸ் வந்து ரெக்கார்ட்ல எழுதிடுவாங்க.
ஓகே மேடம்.
எழுதிட்டாங்கன்னா அதுக்கப்புறம் நம்ம ரீடிங்ஸ் அப்புறமா கொடுத்துடலாம். ரன் பண்றதும் அப்புறமா ரன் பண்ணிடலாம்.
ஓகே மேம். பசங்க லெஃப்ட்டா சொல்லிடுவாங்க. ஓகே ஓகே மேம்.
My students, anybody having doubts? Okay sir. Sir, attendance students.
அட்டெண்டன்ஸ் நம்ம இதுதான் அது எப்படி நோட் பண்றது மேம்?
சார் இப்போ இந்த பார்த்தாலே தெரியுது இல்லையா, கொஞ்சம் பேர் இருக்காங்க, அவங்க நம்ம நோட் பண்ணிடலாம். ஆல்ரெடி இப்போ 39 ஆயிருச்சு, நிறைய பேர் லெஃப்ட் ஆயிட்டாங்க நினைக்கிறேன் இடையில.
முதல்ல 54 இருந்தாங்க மேம்.
இப்போ 39 தான் இருக்காங்க சார்.
ஒன்றும் பிரச்சனை இல்லை.
ஓகே சார். சார் பசங்க வேற யாரும் டவுட் இருக்காங்க? எனக்கு சார்ஜும் முடிய போகுது சார், 14% ஆயிடுச்சு, லேப்பும் க்ளோஸ் ஆயிரும்.
ஓகே மேம், முடிஞ்சதுல மேம். ஆக்சுவலா டைம் போறதானே மேம், எக்ஸ்ட்ரா எடுத்தாச்சு, ஒண்ணும் பிரச்சனை இல்ல. நீங்க க்ளோஸ் ஆயிடுச்சு.
டைம் 4:30 ஆயிருச்சு சார்னா.
எஸ் மேடம்.
ஓகே ஓகே சார். My students, you can give your feedback now. Students, for triple E 1 member and for E&I 1 member and for mechanical 1 member, all your representative give your feedback now. Students, கிளாஸ் எப்படி இருந்துச்சுங்கிறது கொஞ்சம் ஃபீட்பேக் கொடுங்க.
From E&I everything is good ma'am.
ஓகேமா
மேம் எல்லாம் நல்லா புரியுது.
நல்லா அண்டர்ஸ்டாண்ட் ஆகுதா?
அண்டர்ஸ்டாண்ட் ஆகுது மேம்.
ஓகேமா, டவுட் இருந்தா நீங்க கேளுங்க. எப்போனாலும் நீங்க கேட்டீங்கன்னா உங்களுக்கு அது யூஸ் ஆகும். எப்போனாலும் டவுட் கேட்க தான் இன்னும் நிறைய டவுட் உள்ள வந்துகிட்டு இருக்கும். ஸோ நீங்க கேட்கலாம், எந்த டவுட்னாலும் ஓப்பனா கேளுங்க. ஓகே
ஓகே மேம். ஓகே
மெக்கானிக்கல் ஸ்டூடெண்ட், I want feedback from mechanical also. If you have doubt, you can ask. Okay, upcoming class you can ask any doubt. Okay, so from Viva questions also you can ask me. So more are the Viva questions also given here. So you have to take it as homework. I will upload this manual. For each Viva questions you should find the answer. Okay, I will ask you anytime. Okay, from this questions I will be asking some Viva to you. Okay. Okay students, then we can end the section here. Thank you students.
Next class இவ்வளவு நேரம் ஆகுமா மேம்?
நெக்ஸ்ட் கிளாஸ் ஆமா. நெக்ஸ்ட் கிளாஸ் வந்து மெக்கானிக்கலுக்கு வந்து உங்களுக்கு வந்து Thursday ஒரு கிளாஸ் இருக்குது. ஐ திங்க் அன்னைக்கு வந்து மற்ற கிளாஸ் கிடையாது. மெக்கானிக்கல் ஸ்டூடெண்ட் ஆசேஜ் நம்ம அசெம்பிள் பண்ணிடுவோம்.
ஓகே மேம். டைம் எவ்வளவு நேரம் மேம் கிளாஸ்க்கு?
2 to 4:30 மா டைம். ஸோ இன்னும் நிறைய பார்க்கணும் இல்லையா, நம்ம வந்து 2 கிளாஸ்ல எல்லாத்தையும் முடிக்கணும். ஏன்னா நம்ம இப்போ பாதி எக்ஸ்பெரிமெண்ட் வந்து தியரி முடிச்சாச்சு. விர்ச்சுவல் லேப் வந்து ஈஸியா நீங்க பண்ணிடலாம். அதுல ஒரு எக்ஸ்பெரிமெண்ட் நாங்க சொல்லி கொடுத்தா அதர் எக்ஸ்பெரிமெண்ட் நாங்க சொன்ன தியரி வச்சு நீங்களே ரன் பண்ணிடலாம். ஓகே, ஸோ ஆல்ரெடி நாங்க அதுக்கு டெமோ காமிப்போம், நெக்ஸ்ட் கிளாஸ்ல டெமோ காமிக்கும். அதை வச்சு நீங்க விர்ச்சுவல் லேப் எல்லாமே நீங்க ரன் பண்ணிடலாம். ஸோ நெக்ஸ்ட் தியரி ஹாஃப் எக்ஸ்பெரிமெண்ட் அடுத்த ஹவர்லயே முடிச்சிடலாம். ஒரு ஹவர்ல நம்ம முடிச்சிடலாம் எல்லாமே. ஓகே, இந்த ஒரு ஹவர்ல எல்லாம் கவர் ஆயிரும். நீங்க என்ன பண்ணணும்னா ரெக்கார்டை நீங்க கரெக்டா எழுதணும். எழுதி கரெக்டா ரெக்கார்ட் சப்மிட் பண்ணிக்கணும்டா லேபுக்கு முன்னாடி. ஓகே சார். ஆமா சார், குவிட் பண்ணலாமா?
ஓகே பண்ணிடலாம் மேம்.
சார் இப்போ நம்ம